Okay,
Record progress.
so to finish up the review guide for chapter 4 test, at the bottom of the second page, we are starting our word problems. So for 30, we want to write an equation or inequality and solve. So in this case, oh yeah, I don't have it up on the screen. There we go.
Record progress.
All right, so in this case, you always want to find your verb. In this case, it's is at least. So we're looking at an inequality. When the at least is with the verb, you've got an inequality. So we have 4 less than a number. Again, less than is very important because that means that we start with the number and we subtract 4 from it. And then if that is at least 12, then it can be equal to or greater than. So this needs to be greater than or equal to 12. All right, and then also in this case, we don't have any absolute values, so we just have our inequality. So there's the first part. X minus 4 is greater than or equal to 12. And then we solve it. X minus 4 is greater than or equal to 12, and we add 4 to both sides. Whew, got whatever y'all have got. X is greater than or equal to 16. And there's our solution. All right. Again, it is not an absolute value, so we don't have to worry about the disjunction or the conjunction. This is way back to the beginning of chapter 4. All right, the next one, we have 5 more than a number is at most 13. So again, there's our verb is, and it's included with at most. So at most means less than or equal to. 5 more than, that then is your clue that the variable comes first. So we start with a number, we add 5 to it, and that is at most 13. So there's our inequality, and then we solve it. X plus 5 is less than or equal to 13. So we subtract 5 from both sides, and we get X is less than or equal to, works, 8. So there's our solution. 8. All right, so now we're into the word problem part. Jonathan had an 87% average the first 9 weeks. What grade must he get the second 9 weeks in order to finish the first semester with a higher than 90% average? So we know that higher than 90% means that we're looking at an inequality. So we need that number to be greater than 90%, and we're looking at average. So we're going to take what he needs to make for the second quarter, and we need to find an average. So this is his 87 plus whatever he needs to make the second 9 weeks divided by the fact there's 2 9 weeks, and that gives him his average. So here is our initial inequality. Also, he doesn't want it to be 90%. He wants it to be higher than 90%. That's why we don't have an equal to. All right, so now we solve it. 87 plus X divided by 2 greater than 90. So again, if you've got an expression in your numerator or denominator, you treat those like a grouping symbol, and we undo grouping symbols last because we do reverse order of operations. So we've got to divide both sides by 2 first. So now we have 87 plus X is greater than 180. We subtract the 87 from both sides, and he needs to get a total grade greater than, that is a 93. So his grade for the second 9 weeks needs to be greater than 93 percentile in order for him to get greater than 90. All right, everybody with me?
Yeah.
Okay, just make sure. All right, so now we are looking at absolute value. So the fact that we know this is absolute value is because whenever we see something from something, we're talking about distance. So again, we need to be really careful with these. So find all numbers such that 3 times the number is 8 units from -4. So the 8 units from this is our origin. This is where we start. And then the 8 units is our distance. So we have absolute value. Well, 3 times x. So this is 3x. So absolute value of 3x, excuse me, always minus, but it's a -4. And then there's no at most or at least, so this is an equation, is 8. So if we that's like super large. I'll try to get this to fit. So if we simplify this, it is 3x plus 4. The absolute value of 3x plus 4 equals 8. So there's our initial absolute value equation. Now, if I solve it, I gotta make this a little smaller. Okay. All right, so we have to make our 2 equations. Keep this as neat as I can. All right, so 3x plus 4 equals 8. We just copy it without the absolute value, but then we also have to write it with a negative distance. So this 3x plus 4, and then it's the distance up the number line and then down the number line. So that's why it has to be -8 plus 8. And then we just solve it. Subtract 4 from both. I'm just going to do it all the way across. 3x equals 8 minus 4 is 4. 3x -8 minus 4 is 2 negatives, so that gives me -12. Divide everything by 3, and I get the values. X is 4/3, or x is -4. Excellent. So there's our answer. So x equals -4, comma 4/3. All right, number 34 is the real world application of this absolute value inequality. So machine parts are manufactured with a given tolerance. That's what we call the permissible limit of variation. So this was the example that I had in class where I said, if you're making like a bolt, you're making a hole in the panel of a car, that when it gets assembled, a bolt goes through that to attach it to the frame, then maybe it's like a 5 centimeter hole that they need to cut so that the bolt will fit and it will hold it. So if it's too small, the bolt won't go through. It'll strip the bolt and it won't fit properly. If the hole is too large, then it's not going to connect with the, what do they call it? The little grooves in the thread. It's not going to thread in a way that holds it tight so that that panel is attached to the frame of the car. So, but there's like slight millimeters, maybe. If it's 5 centimeters, there might be like 1 millimeter or 0.5 millimeters allowed, that it could be slightly larger than exactly 5 centimeters or slightly smaller, and it will still work. It will still fit the panel successfully and safely to the car frame. So that's what tolerance is. So you've got this range, but it can be a little bigger or a little smaller. So that's why we think of it as a plus or minus. So in this case, we want to write an absolute value inequality representing the length of length of a bolt that is to be 3 centimeters long, with a tolerance value of plus or minus 0.02. Now, if you understand this concept, you can do this in your head. You know that this bolt is allowed to be 3.02 centimeters or 2.98 centimeters. Like it can be both of those and it will still be long enough to fit. But we want to see how you would calculate that, because most of the time when you're doing these, they're not that simple. All right, so we know that our origin, our perfect size for this bolt is 3 centimeters. So this is our origin. Always look at what they set as the ideal standard. What's the standard for something? Now, the distance from that standard is the plus or minus 0.02. So this is your distance. So when we write this as an inequality, this means that the absolute value of x minus the midpoint, in this case 3 centimeters. Now in this case, does it need to be 0.2 larger or more? Right, it can't be any more than 0.2 larger or smaller. So this is a conjunction. So it needs to, that difference between the actual size and the standard, 3 centimeters, must be less than or equal to 0.02, I'm assuming centimeters, but we don't have it written down, so we're just going to leave it that. Here it is, 0.02 centimeters. Okay, so now we have to solve. State the range of acceptable length. So like I said, it could be as small as 2.98 centimeters. It could be as large as 3.02 centimeters and still work. So we know what our answer should be. But let's do the math so that we can kind of see how you figure that out. All right, so we take our absolute value inequality and we have to write two versions of it. So we have x minus 3 is less than or equal to 0.02. And this is where you just copy what you have. With inequalities, when you write the second one, then you're getting your range. This is x minus 3. You have to flip your inequality and change the sign of your distance. So x, the difference between the actual size and standard can be less than or equal to 0.02 or greater than or equal to negative 0.02. All right, so when we solve this, we add 3 to both sides. Be really careful. These are decimals. So x must be less than or equal to 3.02 centimeters. And here, they're unlike signs, so that's just 3.00 minus 0.02. 2, 10, 10 to go 2 is 8, 9, and 2. So x has to be greater than or equal to 2.98. All right, so again, because this is a conjunction, we write it as a combined statement. So x must be greater than or equal to, don't forget your units, 2.98 centimeters, and x has to be less than or equal to 3.02 centimeters. All right, that's it, right? Does that finish it? Okay, good deal. Well, that's it. And go ahead and get started. For now, just those of you that are not in class, make sure that you've got this so that you've got all the notes ready for the test.